Today, we're going to tackle something that looks, well, honestly, it looks pretty much impossible. We're going to stare right into the face of what looks like pure mathematical chaos and see if we can find a simple, elegant truth hiding inside. Okay, take a deep breath and just look at this thing. It's a 9th-degree polynomial. We're talking 10 terms, coefficients up in the thousands. It is an absolute monster. You know, your first instinct might just be to close the tab. And I would not blame you one bit. Finding the 9 different values of x that make this whole thing equal 0, it feels like an impossible task. No, really, just think about it for a second. Where do you even start? There's no obvious way to factor it. Guessing is going to get you nowhere. It feels like a giant, complicated lock, but we don't have a key. Okay, so let's dive right in. It turns out even the most complex big numbers have a key. And for polynomials like this one, that key is a very, very special mathematical tool. This is our key. It's a tool that lets us analyze the relationship between all those big numbers, the coefficients, and the properties of the final answers. Think of it less like a calculator that spits out the answer, and more like a detective's special gadget. We're going to use it to scan for hidden patterns inside our monster equation. So, let's start using our tool. We're going to run a series of calculations based on the numbers in that long equation. Now, we're not actually solving for x yet. Right now, we're just being detectives, gathering clues and looking for any kind of pattern. We run our first calculation, and the result is 0. Okay, that's an interesting start. A nice, clean number. Let's see what the next one gives us. And the second result is also 0. Huh, okay, so that's 2 in a row. And my curiosity is definitely starting to kick in. Let's just try one more. Third, 0. Okay, wait a minute. This is no longer a coincidence, right? We are definitely seeing a clear pattern start to emerge from all that chaos. And in fact, as we keep going, this pattern just keeps holding. The first 8 results, from sub-0 all the way through sub-7, they are all 0. This is a powerful, undeniable pattern. So this brings us to the final calculation. There is just one less to do. We've got 8 zeros in a row. We have to wonder, is the pattern going to hold just one last time? This is really the moment of truth. The whole mystery, everything kind of hinges on what this last number is. Is it going to be another boring 0, or is it going to be something completely different? And there it is. The pattern completely shatters. The final result is not 0 at all. It's 9 to the power of 9. This one single non-zero number is the most important clue we have found. This is the key we've been searching for. So here's the crucial point. This one number changes everything. All of those zeros we found, they weren't just a weird coincidence. They were actually working behind the scenes, simplifying the problem for us. And this final number, it unlocks the whole thing. Because of that incredible string of zeros, our monster polynomial just collapses. It simplifies all the way down to this beautifully simple equation. X to the 9th power equals 9 to the 9th power. That terrifying beast of an equation was just a simple statement in a really, really good disguise. And here's exactly how that magic trick works. It turns out you can rewrite any polynomial like this, where the new coefficients are based on those s values we calculated. Well, since s sub 0 all the way through s sub 7 were all 0, every single one of those middle terms gets multiplied by 0 and just, poof, vanishes. The only things left are the first term, x to the 9th, and that very last term, which we now know is our special number. And from here, believe it or not, the solution is pretty straightforward. The 9 answers we were looking for are simply the 9 different 9th roots of 9 to the 9th. And it gets even more elegant. All 9 of those unique answers can be described by this one single compact formula. It's just a beautiful piece of mathematical shorthand that pins down every single solution. We've gone from a total chaotic mess to a complete, simple answer. So what's the big takeaway from all this? Well, it's that sometimes what looks like an impossibly complex, intimidating problem is really just waiting for the right perspective or the right tool to reveal the simple core that's been hiding underneath all along. And that really leaves us with one final thought. This isn't just about math, is it? It kind of makes you wonder, what other huge, intimidating problems out there, in science, in technology, maybe even in our own lives, are just a hidden pattern away from a simple, elegant solution? Definitely something to think about. Thanks for joining me on this one.